Welcome surfers, it is Joel and this is Rustlers Atom 2.2. In the last atoms we started to understand ownership, and in today's video we talk about copy and clone traits. If you haven't subscribed to this channel yet, maybe this can be the right time to do it. Don't forget it. So let's start. A type in Rust that implements the copy traits behaves much like old school C integers. When you write something, I don't know, something like this, let b equal to a, the value is copied rather than moved only if a implements the copy trait. If you pass a to a function, Rust copies it. Returning a from a function copies it. In all these cases, the original value remain valid. All primitive scalars in Rust are all copy types, so integers, booleans, floats, chars, shared references, all of these types are copy types because implement the copy trait. You very rarely implement copy by hand. Instead, you derive it from small plain data structures. So let's do an example. I can create a new struct called point. Inside this struct I have x, i32, and y, i32. Perfect. If I want to copy this structure, we can derive with this notation some trait. We need the copy trait and the clone trait. In any case, you must derive both because copy is a child of clone. So if I create a new point, let p1 equals to point x2 and y3. Okay, now p1 is our first point, and I can do another point p2 that is equal to p1. My point implement the copy trait. So, in this case, this assignation is a copy. This means that both the value are still valid, so I can print x equals somethings, y equals somethings, and p1 dot x, p1 dot y. Okay, and I can do the same thing with p2 dot x and p2 dot y. Okay, let's clear the console. As you can see, I can use both values, but if I remove my derive and try again, this is not possible because point in this case are not a copy type. Perfect. There are two strict rules for copy. The first one, there can be no custom destruction. So If a type implement drop cannot be a copy type. Second rule, all fields must be copy. If a struct contains, for example, a string that is not a copy type, the struct itself cannot be copy. This is why strings are not copy. If you need to duplicate heap allocated types, you can use clone. Clone is explicit and potentially very expensive, so you decide when to pay the cost of a clone. Let's do an example. Let s1 equal to string from cloning. Okay, we have a string. If I do something like this, s1 is dead in the rest of the code, so the ownership of the string is moved to s2 and I can't use s1. I can just do an example. Print something something s1 and s2. This code can't work. Okay, missing something. Yes, I'm missing. I need to remove something. Okay. I can't use S1 because S1 is moved here and is borrowed after the move. How can I have two different strings? I can simply use the clone function that is available for any type that implement the clone trait. As you can see, if I use clone, the compiler have nothing to complain. Okay, just like copy, you never implement by hand this trait, but you usually derive it. The derive macro simply stitches together the clone function, the clone calls for each field of the structure. Okay, for this video is all. See you in the next atom. Don't forget to like this content and to keep your thinking cap on.